Hello everyone, my name is Andrew and today I'll be talking to you about the famous Lenz law. Nikola Tesla was later able to use this law in his experiment which helped him discover alternating current, which in a sense literally brightened up our world. Now first of all, what actually is Lenz law? There are two definitions that I provided here in this presentation. The first one is a more scientific one and the second one is more easy to understand. The first one states that if a changing magnetic field induces a current in the coil, the electric current is in such a direction that its own magnetic field opposes the change that produced it. Now that's a fairly complex ideology and here is how I simplified it into. Lenz law helps us determine the direction of an induced current in a coil when an induced electric magnetic field is produced. Firstly, an overview of what I'll be going through today. First is what actually is Lenz law, which I've already done in a previous slide. And after that, I'll be showing the focus question for this whole presentation and project. After that will be the prior content, followed by an experiment of dropping a piece of strong neodymium magnet through a copper tube, which demonstrates Lenz law in action. After that will be the history, sample questions, and finally, what are our everyday implications of Lenz law and how it has benefited our lives already. Firstly, the focus question. By investigating the difference in fall time of the magnet, under what circumstances are Lenz law evident in everyday life and how can it be used to benefit the lives of people? Now here's some prior content that I required in order to fully understand Lenz law, since it is a fairly complex term. Firstly, a flux, and after that will be a magnetic field, induced current, right-hand rule, and the SI unit Tesla. So a flux is defined by a force field in a medium or flow of energy over a certain medium, and a magnetic field is a vector field that describes the magnetic influence of an electric charge in relative motion and in magnetized materials, and induced current is current produced by changing magnetic field. Therefore, by changing the magnetic field, you're able to produce an induced current. The right-hand rule is basically sums up into the fact that thumb facing the north of the magnet and finger is wrapped in the direction of the coil, and this helps tremendously with determining the direction of an induced current through the changing magnetic field. And lastly, the SI unit Tesla. It is a magnetic field strength SI unit, and 1 Tesla is defined by 1 volt/second per meter squared. Here is an experiment that I will be doing to demonstrate Lenz law in action. Firstly, drop a strong magnet down a non-conductive copper tube, and secondly, drop the same piece of magnet down a PVC tube, and lastly, record the time for both tries.